Thank you, Mr. Chairman, and good morning again, ladies and gentlemen. It is my great honor to be here as the first speaker of the last day when everybody is exhausted and maybe sleeping. So please hear my presentation as a wake-up call for the following presentations, and I will wake you up by shaking your eyes. Okay, the Fresnel lens is one of the great inventions of the H2 navigation history and has contributed to safety of the navigation for more than 200 years. Therefore, the Fresnel lens, large Fresnel lens such as first order or second order Fresnel lens, has a great historical values. And in Japan, there are still many such large Fresnel lens working as a practical H2 navigation. However, the large Fresnel lens is very vulnerable to the earthquake damage. And in Japan, as an earthquake-prone country, it is important to protect such Fresnel lens from earthquake damage. So today, I'd like to introduce how to preserve large Fresnel lens using modern technology from the earthquake damage. First, I'd like to show you the example of the earthquake damage of the Fresnel lens. In 2007, an earthquake magnitude of 6.9 on the Richter scale hit Sarayama Misaki Lighthouse. Here. And Sarayama Misaki Lighthouse has a second order Fresnel lens made in France at that time. The earthquake was not so large, but many prisms of the lens had cracks. And also, mercury was spilled out from the back. So we replaced the Fresnel lens with a rotating bacon, and the lens was disposed. As you see, large Fresnel lens and mercury bars are very weak to earthquake damage. The first solution was removing mercury bars, and we invented new rotating system using a ball bearing. We call the bearing rotating system. This is a bearing rotating system. It's developed in 1970. It's old, but installed at only 5 lighthouses because the bearing rotating system has some problems or issues. These are the issues of the bearing rotating system. And among these issues, the biggest issue is that the bearing cannot mitigate seismic movements. So we needed another solution, especially how to mitigate seismic movement. So we developed a seismic isolation system for the Fresnel lens. This is a seismic isolation system or device developed in 1998. The system is composed of the cosine ray and rollers. And I will show you how it works. The weight here is 9 tons, the same as the weight of the first order Fresnel lens and its mercury bus of Universal Lighthouse. And here is the seismic isolation device. So now floor is shaking very heavily, and the concrete block here is knocked down. But you see that weight itself is not so moving. So the video will catch another angle, the movement of the seismic isolation device after this video. So here is the cosine layer and rollers, and how its shake is very heavy. This one shows. The displacement of this weight is only less than 20 centimeters. So it can fit even in a small lantern house spaces. So you see the wine glass here did not topple down. So everybody wakes up now. This displacement of the weight, as I said, is only 20 centimeters. So it is possible to fit even in a small lantern house space. This is an analysis result of the Universal Lighthouse. You know the acceleration of the seismic movement at the lantern house floor, and it's reduced by 1/10, less than 1/10 actually. And the system is so successful now installed at 38 lighthouses in Japan Coast Guard. Thank you very much for your attention.